Back in 2018, a pair of NASA-affiliated researchers quietly put a question on the record that almost no one in the scientific establishment was willing to go near. It was simple in the way a knife is simple. If another civilization had risen on this planet long before we did, tens of millions of years before there were cities or writing or anyone alive to remember them, would any of our instruments be capable of finding it? Their answer, which they arrived at only after working through the numbers carefully, was not comforting. In most scenarios, the honest answer is that we would not know. Earth does not archive itself. It consumes itself. Crusts are dragged beneath crusts. Seafloors are swallowed and remade. Entire mountain ranges, given enough time, flatten into plains and then become plains again under another layer of sea. Over a few million years, the skyscrapers, the highways, the cathedrals, the data centers, every physical object a civilization leaves behind gets dissolved, compressed, metamorphosed into rock that looks like every other rock around it. But when the two scientists actually ran their eyes down the long geological record, when they looked for the chemical footprints a technological society might leave smeared across the stone, they noticed something strange. There were signatures, there were moments, there were events in the deep past that looked, at the level of chemistry and isotope and pattern, uncomfortably similar to what our own industrial machine is doing to the planet at this exact moment in history. Events that no conventional model can tidy up without a few loose threads still hanging. Tonight, we are going to walk the length of those threads. From a gash in the geological record 56 million years old, to a fireball in the sky that may have annihilated an entire human chapter 12,000 years ago, to a temple in southeast Turkey that stands older than farming itself. And when we are finished, you will have to make the decision for yourself. Are we the opening act on this planet? Or are we the ones who walked on after something else had already closed its curtain? Before we go any further, if these long-form nighttime investigations are the kind of thing you enjoy, please leave a like and subscribe to the channel. It genuinely helps us keep producing these documentaries. And if you want to take your comfort to another level while you watch or listen, we honestly cannot recommend the Mantis Sleep Sound Mask highly enough. It lets you follow every word of our videos in total darkness and stillness, while also serving as the most comfortable sleep mask you will ever put on. The link is down in the description. Now let us begin. Tonight, we are going somewhere that most documentaries simply will not take you. Not into orbit, not into the trenches at the bottom of the ocean. We are going into a question. A question so unsettling, so slippery, so uncomfortable to hold in the hand, that most professional scientists will not even touch it in conversation, let alone put their name on a paper about it. The question goes like this: what if we are not the first? What if under billions of tons of sediment and stone and silence, under the very ground you are standing on right now, there was something here before us? Not visitors from another star, not gods, something from this earth, something that emerged, that watched the sky, that built, that understood, and that then vanished so completely that we cannot even point to the place where it stood. Over the next couple of hours, we are going to walk the evidence step by step. Real science, real geology, real archaeology, and yes, real mythology. Because the further you push into this question, the more you discover that the border between peer-reviewed research and ancient legend is far thinner, far more porous, than anyone in either camp is comfortable admitting. We will start with a thought experiment two respected researchers published in a mainstream journal, a question that nobody before them had posed in quite this formal a way. Then we will follow them down into a scar buried 56 million years deep in the rock, a scar that looks disturbingly like the footprint our own civilization is currently pressing into the planet. We will examine a catastrophe that struck roughly 12,800 years ago, a catastrophe so violent that it may have wiped an entire chapter of the human story out of the record. We will stand inside a Turkish temple over 11,000 years old, constructed by people who, according to our textbooks, should not have been able to lift a single one of its stones. We will run our palms along the flanks of the Sphinx and ask why a monument in one of the driest landscapes on the planet looks like it has been battered for centuries by heavy rain. We will unroll a map drawn in the year 1513 that appears to depict a continent which Europeans officially would not discover for another 300 years, and which is shown without its ice, a condition that has not existed for many thousands of years. We will climb down into underground cities carved 18 stories deep into living rock, cities designed to house 20,000 people and everything they needed to survive something happening on the surface. And we will listen to the oldest tales our species has ever preserved. Flood myths, destruction myths, stories about a world that ended and a world that began again, told by cultures on every continent, cultures that supposedly never spoke a word to each other. And by the time we have laid all of it out, we will ask the hardest question of the night. What if these scattered threads, the chemistry, the monuments, the anomalies, the legends, are not separate puzzles at all? What if they are fragments, pieces, ragged edges of the same vanished story? A story about a civilization that came first, that reached farther than we have imagined, and that was scrubbed from the planet by forces so enormous that only whispers were left behind. That is the road we will walk tonight. And the road begins with a number, 4.5 billion. That is how old this planet is. Written out fully, it looks like 4,500 million years. A number so immense that the human brain cannot really hold it. We hear it, we nod, we move on, but we do not actually feel it. Not the way we feel a lifetime or a century. And inside that enormous span of time, continents have risen and cracked and drifted across oceans and collided again and split once more. Entire seas have opened and then closed. Mountain chains higher than anything standing today have ground themselves down into grass. The atmosphere itself has been poisoned, rebuilt, poisoned again, and rebuilt again. Life has appeared, branched into a million forms, been nearly extinguished, and come back from the brink. Not once, not twice, at least 5 separate times, in what paleontologists call the Big Five mass extinctions. And against all of that, how long has our civilization been alive? If you define civilization in the traditional way, organized society with agriculture, writing, and permanent buildings, you are looking at roughly 5,000 years. Stretch the definition as generously as you can to include the earliest permanent villages, and you might get to 10,000. That is it. 10,000 years out of 4.5 billion. To give that contrast its proper weight, imagine compressing the entire history of Earth into a single 24-hour day. If the planet was born at midnight, then human civilization does not appear during any of the morning, or any of the afternoon, or any of the evening. It appears in the final fraction of a second before the next midnight rolls around. Not the last second, a fraction of a second, a fragment of a heartbeat. Every city we have ever raised, every empire we have ever built, every language we have ever spoken, every painting, every temple, every song, every satellite, every war, all of it crammed into a sliver of time so razor-thin you could not see it with the naked eye. Now here's the question that does something to your stomach once you let it in. In all of those billions of years, across all of those eons, during which complex, brainy, social, tool-using animals wandered this planet, is it really plausible that intelligence only emerged once? That consciousness, and language, and curiosity, and the urge to build and explore only ever happened in the very last flicker of a 4.5 billion year process? Because think about it for a moment. The ingredients for something like us, or something equivalent to us, have been available for a very long time. Complex animals have roamed this world for more than 500 million years. Mammals alone have existed for over 200 million years. The dinosaurs held the planet for about 165 million years, and some of them possessed relatively impressive brains, lived in organized social groupings, and displayed behavior complex enough to puzzle modern researchers. 165 million years is a lot of time to stumble into innovation. We as a species have been around for roughly 300,000 years, and in the last 12,000 of those, we went from chipping flint to launching probes toward the outer planets. 12,000 years. What could 165 million years produce if conditions lined up right? That is not a fringe question. That is simply a math question, honestly asked. And in 2018, 2 scientists with very real credentials decided it was time to ask it honestly. Their names are Adam Frank and Gavin Schmidt. Frank is an astrophysicist based at the University of Rochester. Schmidt is a climate scientist, and at the time of the paper was director of the NASA Goddard Institute for Space Studies. These are not theorists sitting in fringe corners of the internet. These are tenured, funded, peer-reviewed professionals with institutional reputations to lose. And what they put on paper was not a claim. It was a question, and a formal exploration of that question. A question so plain and so disquieting that for many readers, it permanently altered how they looked at the ground under their feet. They called it the Silurian hypothesis. The name is a wink. It was borrowed from a 1970 episode of the British science fiction show Doctor Who, in which a race of intelligent reptilian beings called the Silurians was revealed to have lived on Earth many hundreds of millions of years before the first human ever walked upright. Frank and Schmidt were not, to be absolutely clear, suggesting that lizard people built high-rises in the Jurassic. What they were asking was more precise and, in a way, far more disturbing. If an industrial civilization had emerged on Earth many millions of years before ours, would our current instruments, our current science, our current geology and archaeology be able to find the evidence? Pause on that distinction. They were not asking whether it happened. They were asking whether, if it had happened, we would even have a chance of knowing. Those are two radically different questions. One is a question about history. The other is a question about the boundaries of what we, as a species, are capable of perceiving in the deep past. And when Frank and Schmidt began to work through the second question, their findings were sobering. For most plausible scenarios, the answer is no. Here is why. Think about what our own civilization will leave behind if we vanished tomorrow. Cities, highways, bridges, glass, concrete, polymers, steel. Now start running the clock forward, not across centuries, across millions of years. Tectonic plates slide against each other. Whole continents inch and then lunge across the planet. Sea levels climb and collapse by hundreds of feet. Mountain belts are thrust upward and then sanded flat. Erosion strips surface after surface off. Subduction zones grab entire slabs of crust and pull them down into the mantle, where temperatures melt the stone back into a liquid. After just a few million years, your cities are not merely hidden or buried. They are obliterated at the molecular level. The atoms that once composed your office towers are now diffused into sedimentary layers, indistinguishable from the surrounding bedrock. After 10 million years, there is no Eiffel Tower, no Great Wall, no pyramids, nothing identifiable as architecture at all. What might survive, barely, are chemical hints. Unusual concentrations of certain elements. Isotopic ratios that do not match natural processes. A thin wafer of synthetic molecules, plastics, pesticides, rare earths, compressed between otherwise ordinary strata. A whisper, not a shout. A whisper. And here is the genuinely unsettling part. Right now, we produce around 300 million tons of plastic every year. That is almost the combined weight of every human being alive. We have set off more than 2,000 nuclear detonations, leaving radioactive isotopes in soils and glacial ice from pole to pole. We have shifted the carbon isotope signature of the entire atmosphere. We have altered the chemistry of the world ocean. We are driving species to extinction at a velocity not seen since the asteroid that ended the age of dinosaurs. If our civilization collapsed tomorrow, and 50 million years from now something intelligent evolved to look back, they would find a strange thin seam in the rock, a spike in carbon-13, an anomaly in nitrogen and phosphorus cycling, microscopic traces of plutonium where no plutonium should be. They would frown. They would run tests. They would eventually wonder aloud what on earth had taken place here. That is precisely what Frank and Schmidt invited the scientific community to do, only in reverse. Turn your head toward the deep past, not toward fossils, not toward ruins, toward anomalies, chemical signatures that refuse to fit, temperature spikes without clean causes, layers of elements appearing and disappearing in the blink of geological time. And when you start to look for things like that, an uncomfortable thing happens. You find them. Not everywhere, not constantly, but in specific windows of Earth's deep history, there are events, strange events. Events where enormous quantities of carbon were injected into the atmosphere across a geologically brief interval. events where global temperatures leapt, events where the chemistry of the oceans reorganized itself violently, events that standard geology explains through volcanic pulses, methane releases, or orbital changes. But events that, if you did not already know the textbook answer, if you were that future scientist looking back at our rocks and not theirs, you might read as the chemical fingerprint of a technological civilization burning through its resources and then collapsing under its own momentum. The most striking of these events has a name. It happened roughly 56 million years ago, and it is where this next chapter begins. Frank and Schmidt, to their immense credit, were painstakingly careful throughout. They underlined repeatedly that they personally considered it extremely unlikely any previous industrial civilization had actually existed on Earth. They were not trying to prove one had, they were trying to ask whether our tools could even detect one if it had. And their honest answer was humbling. Our vision into the deep past is narrower than most of us believe. The geological record has gaps, and large stretches of Earth's pre-quaternary surface are simply inaccessible now. The further back you try to see, the thinner and more fragmentary the evidence becomes. What the Silurian hypothesis really tells us is not that something was here before us. It tells us, uncomfortably, that we cannot decisively prove something was not. And in science, that distinction matters enormously. Absence of evidence is not, and has never been, the same as evidence of absence. Especially when the very planet beneath our feet actively destroys evidence as part of its ordinary functioning. So let us do exactly what Frank and Schmidt suggested. Let us look at the record. Let us go searching for the scars. Let us start with the biggest anomaly of the past 66 million years. A moment when the Earth did something that no volcanic eruption, no single meteor impact, no orbital wobble can fully account for on its own. A moment that, to certain eyes, looks eerily familiar. Chapter 2. The Scar in the Earth. 56 million years ago, something happened to this planet that scientists still cannot completely explain. It was not an asteroid strike. There is no crater. It was not one giant volcanic eruption. There is no caldera large enough. It was something else. Something that arrived quickly, burned intensely, and left behind a mark so deep inside the rock record that every sediment core sampled from that era, pulled from the deepest Atlantic floor or drilled out of Arctic permafrost, tells more or less the identical story. The world caught fire. Not with flame, with heat. Geologists call it the Paleocene-Eocene Thermal Maximum, the PETM. And if you have never heard of it, that is mostly because it rarely leaves the pages of specialist geology and climate journals. It deserves wider attention because the PETM is one of the most extraordinary events in the last 66 million years of Earth's story, and it has one quality that, once you understand it, tends to rob you of a little sleep. It looks nearly identical to what we are doing to the atmosphere right now. Here is what the data tells us. Roughly 56 million years ago, over a geologically brief window of something like 6,000 to 20,000 years, an enormous mass of carbon was dumped into the atmosphere. Current estimates put that release somewhere between 3,000 and 13,000 petagrams of carbon. A petagram is 1 billion metric tons. For context, since the start of the Industrial Revolution, humanity has released around 580 petagrams of carbon. The PETM released, at the absolute minimum, about 5 times that amount, and possibly as much as 20 times, and it unleashed it fast. Not fast by human standards, blisteringly, almost inexplicably fast by geological ones. The consequences were catastrophic. The average global temperature climbed by somewhere between 5 and 8 degrees Celsius. 5 to 8 degrees may sound tolerable until you think about what it actually means. Our entire modern climate conversation is built around trying not to go above 1.5 or 2 degrees. 5 to 8 is not the same planet. During the PETM, the Arctic Ocean climbed to around 23 degrees Celsius, which is about 73 Fahrenheit subtropical temperatures off what is now Antarctica. Ocean temperatures hung around 20 degrees. The polar regions were mild enough for palm trees. Crocodile relatives lived above the Arctic Circle. The tropics became almost uninhabitable. Surface ocean temperatures off the coast of West Africa reached 36 degrees Celsius, roughly 97 Fahrenheit, a level at which many marine species simply cannot function. The deep ocean lost much of its oxygen, a condition geologists call anoxia, and which, in plain terms, means suffocation. Creatures that lived on the deep sea floor died in enormous numbers. It was the largest deep ocean mass extinction in the last 93 million years. Meanwhile, the oceans turned more acidic as dissolved carbon dioxide reacted with seawater. Shell-building creatures, coral, and other life that depends on calcium carbonate structures were devastated. Their shells literally dissolved out from under them. On land, the effects were just as severe. Rainfall patterns buckled and shifted. Regions that had been lush turned to semi-desert. Others were hammered by storms at a scale the fossil record had never recorded before. Plant and animal communities reorganized themselves from the ground up. In Wyoming's Bighorn Basin, which preserves one of the best terrestrial records of the PETM, the entire mammalian community turned over. Old species disappeared. New species poured into the gaps. The landscape was redrawn from root to canopy. And then, over the next 100 to 200,000 years, the Earth slowly recovered. Carbon was pulled back down out of the air. Temperatures dropped. The oceans healed. Life adapted and moved along. What still remains today, is that scar in the stone. A narrow band of unusual chemistry sandwiched between layers of ordinary sediment. A geological whisper that announces that something extraordinary happened here. So what caused it? This is where the story gets interesting, because the honest answer is that scientists do not fully agree. There are several leading hypotheses, and they are not mutually exclusive. The most widely accepted one involves enormous volcanic activity tied to the North Atlantic Igneous Province, a region of intense eruption that flared as Greenland and Europe rifted apart. The idea is that vast intrusions of magma pushed into carbon-rich sedimentary rocks and essentially cooked them, releasing huge quantities of carbon dioxide and methane into the air. Mercury anomalies in PETM-era sediments support this interpretation because mercury is a reliable signature of volcanic activity. A second hypothesis points to the destabilization of methane hydrates on the ocean floor. These are ice-like structures in deep-sea sediments that lock up enormous volumes of methane, a greenhouse gas far more potent than carbon dioxide over the short term. If ocean temperatures crept up even a little, those hydrates could have melted and cascaded their methane into the atmosphere. Initial warming triggers more methane release, which drives further warming, which releases still more methane. A feedback loop. A runaway. A process capable of explaining both the raw magnitude and the terrifying speed of the PETM carbon spike. A third hypothesis invokes orbital forcing. Shifts in Earth's orbit around the Sun, specifically in its eccentricity and precession, alter how much sunlight different parts of the planet are receiving at different times. Recent work suggests the onset of the PETM happened to coincide with an extreme in precession during a maximum in eccentricity, meaning Earth was bathing in an unusually high dose of solar energy. That may have been the initial shove that set the whole cascade in motion. Most current researchers lean toward a hybrid. A volcanic pulse provided the initial injection of carbon, orbital forcing amplified the warming, and methane hydrate destabilization kicked the whole machine into overdrive. Together, those three mechanisms can explain most of what we see in the rocks. Most, but not all of it. Here is the detail that sits quietly at the edge of the conversation, the one Frank and Schmidt were careful to highlight without overclaiming. The speed and chemical signature of the PETM's onset does not perfectly match any single natural mechanism we can describe. The carbon isotope excursion, the dramatic swing in the ratio of carbon-12 to carbon-13 in sediments from that era, shows a sharp negative shift. That kind of shift is consistent with the release of biogenic carbon, meaning carbon that originally came out of living tissue. Fossil fuels are biogenic carbon. When you burn coal, oil, or natural gas, you release carbon with a specific isotopic fingerprint, a fingerprint that is remarkably close to what is observed at the PETM boundary. Now, does that mean an industrial civilization caused the PETM? No, absolutely not. There is no direct evidence that it did, and the volcanic and methane hydrate explanations remain the most parsimonious. Frank and Schmidt said as much in their own paper. They explicitly stated that they strongly doubt any previous industrial civilization existed. But what they also said is this: if such a civilization had existed and had burned through its fossil fuel reserves in a manner similar to our own, the chemical signature it left behind would look very much like what we already see at the PETM. In many respects, the two signals would be indistinguishable from each other. That is the uncomfortable part. Not that the PETM was caused by a civilization, it almost certainly was not. But that if it had been, we might not be able to tell. Because the paradox at the heart of the Silurian hypothesis is this: the more sustainable a civilization is, the smaller its geological footprint. A society that runs mostly on solar, wind, and geothermal leaves almost nothing behind in the rock. A society that runs on fossil fuels leaves a trace that looks exactly like a natural carbon release event. And a society that rises and falls within a geologically brief window, let us say a few thousand years, leaves a seam in the sediment so thin it can fall entirely into the unexamined gap between one core sample and the next. We are hunting for a needle in a haystack, except the needle is made of the same stuff as the hay. The PETM as a whole lasted roughly 200,000 years from the initial spike through to full recovery. Our own industrial civilization has existed for about 300. If something structurally similar to us had lived and died 56 million years ago, its entire arc from first foundry to final collapse would be thinner than a sheet of paper in the rock record. In a great many core samples, that sheet would simply not be preserved at all. It would have been compressed into neighboring layers dissolved by percolating fluids, or long since subducted into the mantle. So what are we left with? We are left with the event that stands as the best ancient analog for modern climate change. An event that dumped a colossal mass of carbon into the atmosphere in a geologically short time. An event that warmed the planet by 5 to 8 degrees and devastated both marine and land ecosystems. An event whose precise trigger remains debated after decades of hard scientific work. And an event that, purely as a matter of chemistry, is indistinguishable from what an industrial civilization would leave behind. We are left with a scar. A deep ancient scar in the rock. And a question with no comfortable answer. But the PETM is not the only scar. It is simply the oldest and deepest within the recent geological past. If you fast forward from 56 million years ago to something far closer to our own era, you run into another event, another catastrophe, another disruption that no one has cleanly explained. And this one does not just leave chemistry in the rocks. It leaves bodies. Roughly 12,800 years ago, at the very tail end of the last ice age, something struck the Earth, or exploded above it, or rained down on it in fragments. The details are still being argued. What is not being argued is what happened in the aftermath. Temperatures that had been climbing steadily for thousands of years suddenly crashed. The planet was hurled back into near-glacial conditions in what appears to have been a matter of decades, possibly even years. The warm period that had been melting ice sheets and opening fresh lands for human habitation was abruptly interrupted by a brutal cold snap that lasted over 1,200 years. Scientists call that cold snap the Younger Dryas. It is named after a small Arctic wildflower, Dryas octopetala, whose pollen suddenly reappears in European sediment layers that had previously been dominated by warmer-loving plants. The flower's return was a quiet signal. Winter was coming back. For decades, the conventional explanation has come from oceanography. The dominant view has held that a massive pulse of fresh water from melting North American glaciers, possibly the catastrophic draining of a vast glacial lake called Lake Agassiz, poured into the North Atlantic and disrupted the ocean's thermohaline circulation. That circulation, sometimes called the Atlantic Conveyor, ferries warm tropical water northward and keeps Europe and the North Atlantic comparatively mild. Dump enough cold fresh water into the system quickly enough, the theory goes, and the conveyor shuts down. Warm water stops moving north. Europe freezes. The effects ripple across the globe. It is a solid theory. It accounts for much of the data, but it does not quite account for all of it. And in 2007, a group of scientists proposed something very different as the trigger, something that would rewire the conversation about the Younger Dryas forever. They proposed a comet. And that comet, they argued, did more than flip the climate. It may have erased an entire civilization from the face of the Earth. That is where we are going next. Chapter 3. The Comet and the Catastrophe. Picture the world as it looked 12,800 years ago. The enormous ice sheets that had buried much of North America and Northern Europe for tens of thousands of years are in retreat. The climate is warming. Mammoths still graze the tundra. Saber-toothed cats still stalk the forest edges. Giant ground sloths, some the size of small cars, browse the woodlands of the Americas. Across North America, a culture of highly skilled hunters, known as the Clovis people, is thriving. They take their name from a site near Clovis, New Mexico, where their distinctive stone spear points were first unearthed. Those points are extraordinary, fluted, symmetrical, deadly, almost sculptural. They represent some of the finest flaked stonework of the prehistoric world. The Clovis are flourishing. The ice is retreating. The future looks wide open. And then, inside what appears to be a single human lifetime, the whole world changes. The megafauna vanishes. Not slowly, not through the gradual attrition of thousands of years. They disappear. In North America alone, 35 genera of large animals go extinct in a geological eye blink. Mammoths, mastodons, giant sloths, short-faced bears, American lions, saber-toothed cats, dire wolves, giant beavers the size of black bears, American camels, American horses, all of them gone. One 2008 study remarked that the extinction appears to have been catastrophic, too sudden and too extensive for either human hunting or gradual climate change alone to have been the primary cause. The Clovis culture evaporates at the same moment. Their distinctive fluted points vanish from the archaeological record. Whatever replaced them is different, simpler, less sophisticated, as if the craft and the continuity that had produced those beautiful points had been interrupted, broken, forgotten, and the climate flips like a switch. Temperatures that had been climbing for thousands of years drop. In parts of Greenland, annual average temperatures may have plunged by 10 to 15 degrees Celsius within decades. The warm period ends. Winter comes back. The Younger Dryas has begun. The conventional explanation, the freshwater pulse from Lake Agassiz shutting down the Atlantic conveyor, can account for the climate reversal, but it does not neatly explain the simultaneous extinction of megafauna across multiple continents. It does not explain the sudden vanishing of the Clovis culture, and it does not explain what a growing body of research has uncovered at the boundary layer between the warm interval and the Younger Dryas, a layer that contains things it has no business containing. In 2007, a team of about 20 scientists led by Richard Firestone, Alan West, and others presented their findings at a meeting of the American Geophysical Union. The claim was extraordinary. At multiple sites across North America, at sediments dating to approximately 12,900 years before present, they had found a distinct layer containing an unusual combination of materials. Nanodiamonds, microscopic diamonds that form only under extreme heat and pressure. Magnetic microspherules, tiny metallic spheres that form when rock or soil is melted and then resolidifies in midair. Elevated levels of iridium, an element rare on Earth's surface but common in asteroids and comets. Shocked quartz, grains of quartz bearing fracture patterns produced only by extreme pressures associated with cosmic impacts or nuclear detonations. Carbon spherules, soot, evidence of intense, widespread burning. The team argued that a large, low-density extraterrestrial object, most likely a fragmented comet, had either exploded above or struck the northern hemisphere roughly 12,900 years ago. The explosion, they estimated, would have been equivalent in energy to thousands or even tens of thousands of nuclear weapons detonating at once. The shock wave, thermal pulse, and resulting firestorm would have devastated life across a vast swath of territory. Dust and soot thrown into the upper atmosphere would have blocked sunlight for months, triggering rapid cooling. An impact on or over the Laurentide ice sheet in North America could have destabilized the ice itself, releasing enormous volumes of meltwater into the Atlantic and shutting the thermohaline conveyor down. One event, many effects. In one stroke, you get the megafauna extinction, the collapse of the Clovis people, the wildfire evidence, the climate flip, and the ocean circulation shutdown. One trigger, Cascading consequences. The Younger Dryas impact hypothesis was born. The reaction from the scientific community, to put it politely, was intense. The hypothesis was immediately controversial. Critics pointed out that there was no obvious crater. Proponents answered that a comet disintegrating in the atmosphere, an airburst rather than a ground impact, would not necessarily leave a traditional crater behind. The Tunguska event in Siberia in 1908, when a relatively modest extraterrestrial object exploded above the ground, flattened around 2,000 square kilometers of forest without leaving a crater. Scale that up by orders of magnitude, and you have something like the Younger Dryas event. Critics challenged the nanodiamonds. Proponents refined their methods and found them at additional sites. Critics questioned the microspherules. Proponents documented them at more than 50 locations across multiple continents. Critics argued that the whole pattern could be explained by ordinary terrestrial processes. Proponents pointed to the synchronicity. All of these markers appearing in the same stratigraphic layer at the same time at sites scattered across North America, Europe, parts of the Middle East, and parts of South America. As one research team bluntly put it, the only reasonable conclusion, given the synchronicity, is that a major cosmic impact occurred at that time, and its timing is so close to the Younger Dryas cooling that a causal connection is highly likely. The argument is still going. Mainstream scientific consensus still favors the freshwater pulse as the trigger for Younger Dryas cooling. The impact hypothesis remains controversial, but it has not gone away. In fact, in recent years, fresh evidence has given it new momentum. In 2018, researchers announced the discovery of the Hiawatha crater beneath the Greenland ice sheet, a massive impact structure more than 19 miles wide, buried under nearly 3,000 feet of ice. Initial age estimates placed it within the Younger Dryas window, around 12,800 years old. More recent work has pushed that age back somewhat, and the debate over its exact timing continues, but its existence proved that large, recent impacts in that general time frame are not impossible. They are documented. In 2025, researchers published findings about a crater-like depression in Louisiana nearly 1,000 feet long that appears to have been carved by a cosmic airburst dating to roughly 12,800 years ago. The site contained the same markers found at other Younger Dryas boundary locations: microspherules, shocked quartz, glass formed at temperatures exceeding 2,000 degrees Celsius. The characteristics matched those found at nuclear test sites in New Mexico and Kazakhstan, where atomic detonations had produced very similar material. Meanwhile, deep-sea sediment cores pulled from Baffin Bay between Greenland and Canada yielded silica and iron-rich microspherules at the same stratigraphic level, providing marine data to reinforce the findings from land. The overall picture is becoming harder to dismiss. But here is where this story takes a turn that matters enormously for our investigation. Because the Younger Dryas impact hypothesis is not only about climate science or mass extinction, it is also about what may have been lost. If a cosmic catastrophe smashed into the Earth 12,800 years ago, what was the state of human civilization at that exact moment? The standard archaeological narrative holds that humans at the end of the Ice Age were hunter-gatherers. Small, roving bands following herds, gathering berries, living in temporary shelters. No cities, no agriculture, no writing, no permanent buildings, simple people leading simple lives. But that narrative has been under pressure for years, and the discovery that finally cracked it open came not from a scholar in a library, but from a dusty hilltop in southeastern Turkey. A site that should not exist. A site that, according to everything we thought we knew about human history, is impossible. It is called Göbekli Tepe, and it changes everything. Because Göbekli Tepe was not built after the Younger Dryas. It was built right at the end of it. Or, as some researchers whisper, possibly built to commemorate what was lost during it. The oldest portions of the site date to approximately 11,600 years ago, which is exactly the moment when the Younger Dryas cold period ended and the world began to warm once more. The timing is either the single most dazzling coincidence in all of archaeology, or it is not a coincidence at all. Graham Hancock, the controversial author of Fingerprints of the Gods and host of the Netflix series Ancient Apocalypse, has argued for decades that the Younger Dryas comet annihilated a sophisticated Ice Age civilization, that the survivors of that catastrophe scattered, carrying fragments of their knowledge to indigenous peoples around the world, that Göbekli Tepe was constructed by those survivors, or by people they taught, that the flood myths present in virtually every culture on Earth are fragmentary memories of the very real flooding that accompanied the end of the Ice Age, amplified and distorted by 12,000 years of retelling. Mainstream archaeology dismisses most of Hancock's broader claims. They point out that there is no direct evidence of an advanced pre-Younger Dryas civilization, no cities, no writing, no technology beyond stone tools. And in science, extraordinary claims require extraordinary evidence. That evidence, they argue, simply is not there. But the mainstream narrative has its own problem, because Göbekli Tepe exists. And Göbekli Tepe should not exist. Not according to the timeline we were all taught. Not according to the story of civilization that says first came agriculture, then villages, then temples. Göbekli Tepe says temples came first. And that inverts the entire sequence. That shatters everything we thought we knew about what human beings were capable of 12,000 years ago. And it raises a question no amount of academic dismissal can quite bury. If hunter-gatherers built Göbekli Tepe, what else could they build? And what else might they have built that we have not yet found, or that was obliterated by the very catastrophe that bookends the world we know? Chapter 4. The Temple That Should Not Exist. Southeastern Turkey. The Jermis Mountains. A landscape of rolling hills baked dry beneath an open sky. 15 kilometers northeast of the ancient city of Sanliurfa, a hill swells gently out of the surrounding terrain. It is not a natural hill. It is a tell, an artificial mound built up over thousands of years of human activity accumulating upon itself. The locals call it Göbekli Tepe, which roughly translates as Potbelly Hill. For centuries, farmers worked the soil around it, occasionally turning up worked stone fragments and carved rock shards, which they stacked along the edges of their fields and otherwise ignored. In 1963, a joint survey team from Istanbul University and the University of Chicago visited the site. They noted the worked stones. They recorded the spot as a medieval cemetery. And they moved on. For 31 years, one of the most important archaeological discoveries in human history sat in plain sight, dismissed, unexamined, and unread. Then, in 1994, a German archaeologist named Klaus Schmidt arrived in the region. Schmidt had been working at another ancient site called Navali Kori and was actively looking for sites of similar antiquity in the area. When local residents directed him to the hilltop, he recognized the stone fragments immediately for what they were. These were not medieval cemetery stones. These were prehistoric. And they were old. He began excavating in 1995. What he and his team pulled out of the earth was so extraordinary that it took years for the archaeological world to fully absorb what had been found. Massive T-shaped limestone pillars, some nearly 16 feet tall, some weighing as much as 20 tons, arranged in circles, embedded in walls of smaller masonry, and covered in intricate carved reliefs. Foxes, lions, boars, snakes, vultures, scorpions, abstract symbols, and on some pillars, arms carved in relief, running down the sides of the stone with hands clasped at the front, as if the pillars themselves were stylized representations of human beings. Giant stone people standing in circles, facing one another in the dark. The circles are enormous. The largest measures about 66 feet across. Each enclosure contains 2 central pillars that are taller and more elaborately carved than those in the surrounding ring. 20 such enclosures have been identified so far, although geophysical surveys suggest many more remain buried beneath the hill. Only a fraction of the site has been excavated. What still lies under the rest of it is unknown. And the dating is the thing that shattered the textbook. Radiocarbon analysis placed the oldest structures at Göbekli Tepe at approximately 9,500 BCE, that is 11,500 years ago, more than 6,000 years older than Stonehenge, more than 6,000 years older than the Egyptian pyramids, older than any permanent human structure previously known to exist. Let that settle. 11,500 years ago, that is before agriculture, before pottery, before metallurgy, before the wheel, before writing, before every single element of what we traditionally define as civilization. The people who built Göbekli Tepe were, by every other line of evidence, hunter-gatherers. They had no domesticated plants, they had no domesticated animals, they had no permanent villages, they had no written language, and yet they built this. They quarried limestone blocks weighing up to 20 tons out of outcrops hundreds of yards away. They shaped those blocks into precise T-forms using nothing but flint tools. They carved elaborate animal reliefs into the hard stone, work that requires not only manual skill but artistic sophistication and high-level symbolic thinking. They transported the massive pillars to the hilltop, set them into carefully planned circular arrangements, and oriented them with precision. And they did this not once, not as a single burst of collective effort, but repeatedly over centuries, building enclosure after enclosure, each one reflecting a coherent architectural vision. Computer modeling conducted by researchers and published in the Cambridge Archaeological Journal revealed that the builders used geometric principles to plan the site. The three main enclosures are connected by an equilateral triangle, suggesting the entire complex was conceived as a single unified design rather than a series of structures casually added over time. The builders used stretched ropes to establish distances and angles. They worked with a degree of planning and coordination that implies an organizational sophistication far beyond what archaeologists had previously attributed to hunter-gatherer societies. And here is what deepens the puzzle. After centuries of active use, the site was deliberately buried, intentionally. Around 8000 BCE, the people who had built and used these structures filled them in with earth, rubble, and refuse. They did not abandon the site and let nature take it. They actively covered it, as if they were sealing it, protecting it, or hiding it. Why? Nobody knows. Theories range from ritual closure, a symbolic ending of a religious era, to practical concealment, burying the site from enemies or from a new generation that had adopted a different faith. Some alternative researchers have speculated more dramatic reasons. But whatever the motivation, the deliberate burial is what preserved Göbekli Tepe in such remarkable condition. Without that covering, 12,000 years of erosion, earthquake, and weathering would have reduced the site to rubble. The burial was, intentionally or not, an act of preservation. Now, what does Göbekli Tepe mean for our larger story? Why does it matter to the question of whether we are Earth's first civilization? It matters because it broke the model. Before Göbekli Tepe, the accepted sequence of human development went like this. Agriculture came first. Once people learned to farm, food surpluses appeared. Food surpluses allowed permanent settlements. Settlements allowed specialization. Specialization allowed social hierarchies. Hierarchies produced organized religion. Organized religion eventually produced the desire and the ability to build monuments and temples. That was the sequence. Farm first, then build. Göbekli Tepe reversed it. The temple came first, long before anyone in the region had domesticated a single grain of wheat, long before anyone had corralled a single sheep or planted a single row of barley. People were gathering on this hilltop to carve and raise enormous stone monuments. The desire to create sacred space, to build something monumental and permanent, preceded agriculture. It may, in fact, have driven agriculture into existence. Klaus Schmidt proposed exactly this. He suggested that the construction of Göbekli Tepe required such a large labor force, drawn from across a wide region for extended periods, that the sheer need to feed those workers pushed people toward the deliberate cultivation of wild grains. Building the temple created the need for farming, not the other way around, and there is evidence supporting this. Just 20 miles from Göbekli Tepe, geneticists located the world's oldest genetically confirmed strains of domesticated wheat. Radiocarbon dating places that domestication event at roughly 10,500 years ago, just 5 centuries after the construction of Göbekli Tepe began. The cradle of agriculture and the world's oldest temple are next-door neighbors. But there is an even more striking alternative reading. What if Göbekli Tepe is not the beginning of something? What if it is the end? What if the knowledge, the organizational skill, the architectural sophistication, the entire carved symbolic language on those pillars did not spring up out of nothing in the heads of nomadic hunters? What if it was inherited, passed down from a previous tradition, a previous culture, a previous level of human achievement that was destroyed or disrupted by the catastrophe at the end of the Ice Age? The timing aligns. The Younger Dryas ended approximately 11,600 years ago. The oldest structures at Göbekli Tepe date to approximately 11,500 years ago. The gap between those two numbers is negligible. It is as if, the moment the cold released its grip and the world began to warm again, someone started building. Immediately, urgently, with a level of skill and knowledge that implies they did not invent it on the spot, they already had it. On one of the most famous pillars at Göbekli Tepe, Pillar 43, sometimes called the Vulture Stone, a complex scene is carved. A vulture holds a round object, possibly a sphere, possibly a head. Below it, a scorpion. Around them, other animals and abstract symbols. Some researchers, notably at the University of Edinburgh, have proposed that the carvings encode astronomical information, that the animals represent constellations, that the round object represents the sun, that the entire scene depicts a specific moment in time, a date encoded in stone using the positions of the stars. The date they propose, approximately 10,950 BCE, falls right at the onset of the Younger Dryas. If this interpretation is correct, and it remains debated, then Göbekli Tepe is not simply a temple, it is a memorial, a record carved in stone to commemorate a catastrophe, a message left by the survivors of something terrible, addressed to the future, a way of saying, we remember what happened, we remember the fire from the sky. Whether you accept that interpretation or not, one thing is beyond serious dispute. Göbekli Tepe proves that human beings 12,000 years ago were capable of far more than textbooks had ever allowed. If they could build that, what else could they build? And if whatever came before it was destroyed, how would we even know? The archaeological record is not complete. It is a Swiss cheese of absences and gaps. Only a tiny fraction of the Earth's land surface has been excavated. Only a tiny fraction of what once existed has been preserved at all. And underwater, where the coastlines of 12,000 years ago now lie beneath hundreds of feet of seawater raised by post-glacial melt, entire landscapes remain unexamined. If there was a coastal civilization during the Ice Age, a people who built along shorelines that now sit far beneath the waves, we would not know. We have barely begun to look. Göbekli Tepe sits on a mountain ridge far above the sea. That is why it survived. Whatever stood at sea level did not. Chapter 5. Water on the Sphinx. Now we travel to Egypt. To the Giza Plateau. To the most famous monument on the surface of this planet. The Great Sphinx. It crouches beside the Great Pyramid, facing due east, staring unblinking at the rising sun with an expression that has not changed in thousands of years. A limestone body the size of a large building. A human head set on a lion's frame. Carved not from blocks assembled upon each other like the pyramids, but from the living bedrock of the plateau itself, cut downward from the surface and liberated from the rock that surrounded it. According to mainstream Egyptology, the Sphinx was carved around 2500 BCE during the reign of the pharaoh Khafre, who also built the second largest of the Giza pyramids. The evidence for that dating is largely circumstantial. There is no inscription on the Sphinx itself naming its builder. There is no contemporary record of its construction. The attribution to Khafre rests on its proximity to his pyramid, its broad stylistic similarity to Old Kingdom art, and a damaged stela positioned between the paws of the Sphinx that may reference Khafre's name, though the relevant portion of the inscription is badly eroded and fragmentary. For most of the 20th century, that dating was never seriously questioned. The Sphinx was carved by Khafre around 2500 BCE, case closed. Then, in 1990, a geologist walked into the Sphinx enclosure and saw something that should not be there. His name was Robert Schoch. He held a PhD in geology and geophysics from Yale. He was an associate professor at Boston University. He was not an Egyptologist, he was not a mystic, he was not on a hunt for lost civilizations. He had been invited to Egypt by John Anthony West, an independent researcher who had long suspected that the Sphinx was older than the official dating. West wanted a professional geologist to examine the rock with fresh eyes. Schoch went, expecting to confirm the conventional date. It took him only seconds to notice the problem. The walls of the Sphinx enclosure, the trench that had been carved down into the bedrock when the Sphinx's body was freed from the surrounding limestone, displayed deep, rounded vertical grooves. Undulating surfaces, fissures that were wider at the top than at the bottom. The profiles were unmistakable to any trained geologist. They were the product of water erosion, and specifically of rainfall erosion. Water running down vertical rock surfaces over long periods, carving characteristic rounded channels and dissolving the limestone from above. The problem is that the Sphinx sits on the edge of the Sahara Desert. The Giza Plateau has been essentially arid for the last 5,000 years. Rainfall in the area is minimal. The dominant weathering force on the plateau is wind and wind-blown sand, which produces an entirely different erosion pattern. Wind erosion creates horizontal striations, sharp edges, angular profiles. The surfaces on the Sphinx enclosure walls did not look like that at all. They looked like something that had been battered by centuries of heavy, sustained rain. Schoch examined other structures on the Giza Plateau that are securely dated to the Old Kingdom, to Khafre's era, including the rock-cut tombs nearby, carved from the very same geological formations. They showed erosion consistent with wind and sand, sharp horizontal layers, angular surfaces, desert weathering. The Sphinx and its enclosure showed something entirely different: deep vertical grooves, rounded surfaces, water damage. If both sets of structures had been carved at the same time, in the same rock, under the same climate, they should display identical weathering patterns. They do not. The simplest explanation, Schoch argued, was that they had not been carved at the same time. The Sphinx was older, much older, old enough to have been exposed to a period of prolonged, heavy rainfall. When did Egypt last experience that kind of rainfall? During what climatologists call the African humid period, roughly from 12,000 to 5,000 years before the Common Era, the Sahara was not a desert. It was green savanna. Lakes glittered across what is now bone-dry sand. Rivers flowed through what is now empty nothing. Rainfall was abundant. The climate was wet enough to support large populations of animals and humans. Rock art in what is now the Deep Sahara shows people swimming, herding cattle, and living along waterways that have been gone for millennia. Schoch initially estimated that the Sphinx had been carved before 5000 BCE. As his research continued, he pushed that estimate further and further back, eventually suggesting that the core body of the monument might date to the end of the last ice age, around 10,000 BCE, or perhaps even earlier. A date that would make the Sphinx not 4,500 years old, but 12,000 years old, possibly more. The reaction from mainstream Egyptology was predictable and ferocious. Mark Lehner, one of the world's leading authorities on the Giza Plateau, dismissed the hypothesis bluntly. "You do not," he said, "overthrow Egyptian history based on one phenomenon like a weathering profile. That is how pseudoscience is done, not real science." Other critics argued that the erosion could be explained by salt weathering, by periodic soaking from Nile floods, by moisture absorbed through saturated sand that periodically buried the Sphinx. Geologist James Harrell of the University of Toledo proposed that rainwater slowly seeping through the porous sand that had buried the Sphinx for long stretches of history could produce similar erosion patterns without requiring a wetter climate. These counter-arguments have genuine merit. The geology of the Giza Plateau is complex. Multiple weathering processes run at once, and the attribution of the Sphinx to Khafre fits neatly into the overall layout and architectural sequence of the Giza complex. Moving the Sphinx's date back by thousands of years creates enormous problems for the conventional archaeological timeline. If the Sphinx is 12,000 years old, who built it? There is no evidence of any civilization in Egypt capable of such a monumental undertaking at that time. But Schoch pushed back. He conducted seismic surveys around the base of the Sphinx using sledgehammers on steel plates to generate sound waves that penetrated into the bedrock. The reflected signals revealed the depth of subsurface weathering, how far down into the rock the erosion extended. The data showed extraordinary depth, deeper than what you would expect for a monument only 4,500 years old. And the depth was consistent across the enclosure, suggesting prolonged, uniform weathering from above. Rainfall, not localized flooding, not sand moisture. Rainfall. He also highlighted a detail that is genuinely hard to dismiss. The head of the Sphinx is smaller than the body, disproportionately so. Precise measurements confirm it. The head is too small relative to the body's scale. And the tool marks on the head are relatively recent, consistent with Old Kingdom craftsmanship. That led Scholk and others to propose that the head had been recarved. That the original head, whatever it depicted, had been so badly weathered that a later pharaoh had recarved it into the human form we see today. A smaller head carved from a larger, eroded original would explain both the disproportionate size and the different tool marks. If the body is older and the head was recarved during the Old Kingdom, the discrepancy in weathering makes sense. The body endured thousands of years of rainfall. The head was freshly carved around 2500 BCE and has only ever experienced desert conditions. There is one more observation that deepens the mystery. The Sphinx faces due east. On the morning of the spring equinox, it stares directly at the rising sun. But because of a phenomenon called precession, the slow wobble of Earth's axis over a roughly 26,000-year cycle, the constellation visible on the eastern horizon at sunrise on the equinox changes across that span. Today, the constellation is Pisces. 2,000 years ago, it was Aries. 4,000 years ago, around the time Egyptologists formally date the Sphinx, it was Taurus, the bull. But if you wind the sky back to roughly 500 BCE, the constellation rising on the eastern horizon at sunrise on the spring equinox was Leo, the lion. A lion monument facing east, staring at the constellation of the lion at sunrise on the equinox. The alignment is precise, the symbolism is obvious, and the date, 500 BCE, falls squarely within the window Scholk proposed for the original construction. Coincidence? Perhaps, but it is a coincidence that has kept researchers arguing for 3 decades. The Sphinx debate remains unresolved. Mainstream archaeology firmly dates the monument to Khafre's reign. The geological evidence, at minimum, raises questions that have not been satisfactorily answered. And the broader implications are enormous. If the Sphinx is 12,000 years old, it means someone was in Egypt at the end of the Ice Age, with the knowledge, the organization, and the motivation to carve a monumental sculpture out of bedrock. Not a small carved stone, not a decorated cave wall. A monument the size of a building. Who were they? Where did they come from? What else did they build? And if a catastrophe swept the world at the close of the Ice Age, what happened to them? These questions do not have answers. Not yet. But they have echoes. And those echoes turn up in unexpected places. Like on a piece of gazelle skin, drawn in 1513 by a Turkish admiral. A map that appears to show something no one in the 16th century should have known about. A continent no European explorer would officially reach for another 300 years. A continent shown without its ice. That map is our next destination. Chapter 6. The Maps That Came Too Early. In 1929, in the basement of the Topkapi Palace in Istanbul, a German theologian named Gustav Adolf Deissmann was sorting through old documents and artifacts at the request of the Turkish government. The palace had served as the administrative heart of the Ottoman Empire for centuries, and its archives held thousands of uncatalogued items, maps, manuscripts, letters, administrative records, all crammed into storage and largely forgotten. Deissmann pulled a rolled piece of animal hide off a dusty shelf. It was gazelle skin, dried and aged. He unrolled it carefully. What he found was a map, a fragment, clearly, roughly a third of what had once been a larger chart. But even as a fragment, it was extraordinary. The map had been drawn and signed in 1513 by an Ottoman admiral and cartographer named Hachi Ahmed Muhiddin Piri, known to history as Piri Reis. He was a seasoned sailor, a former privateer who had served in the Ottoman Navy, and a devoted collector of geographical knowledge. In his own annotations on the map, written in Ottoman Turkish, Piri Reis explained that he had compiled his chart from approximately 20 different source maps and older charts. 8 were Ptolemaic maps based on the geographical knowledge of the ancient Greeks. 4 were Portuguese charts from recent explorations. 1 was an Arabic map, and 1, Piri Reis claimed, had been drawn by Christopher Columbus himself, a map that has since been lost to history. The Piri Reis fragment is the only known surviving trace of any part of Columbus's original chart. The map itself is a portolan chart, a type of nautical map used for navigation, featuring compass roses and a network of rhumb lines. It depicts the western coast of Africa, the Iberian Peninsula, and the eastern coast of South America in remarkable detail for its era. The coastline of Brazil, in particular, is rendered with a level of accuracy that impressed modern cartographers when the map was first rigorously studied. But it is the feature at the very bottom of the fragment, below the South American coastline, that propelled the Piri Reis map into the realm of mystery and lasting controversy. The map depicts a landmass, a large, continuous landmass extending to the south and curving eastward. A landmass that, to some eyes, resembles the northern coast of Antarctica. The problem is immediate. Antarctica was not officially discovered until 1820, more than 300 years after Piri Reis drew his chart. No European, no Ottoman, no known explorer had reached Antarctica in 1513. If the southern landmass on the Piri Reis map really is Antarctica, how did Piri Reis know it was there? The mystery deepened considerably when, in 1965, Professor Charles Hapgood of the University of New Hampshire published a book called Maps of the Ancient Sea Kings. Hapgood and his students had studied the Piri Reis map in detail and flagged several anomalies. The map appeared to use a form of projection similar to the Mercator projection, a method for representing the curved surface of the Earth on a flat surface that European cartographers did not widely adopt until later in the 16th century. The map showed geographical features with a degree of accuracy that seemed to exceed the navigational capabilities of the early 1500s. But the most startling claim concerned the southern landmass. Hapgood argued that it was not merely Antarctica. It was Antarctica without its ice cap. The coastline depicted, he claimed, corresponded not to the ice-covered coast visible today, but to the actual rock coastline of the continent, which lies buried beneath thousands of feet of glacial ice. A coastline only mapped in the 20th century through seismic surveys and satellite imaging. If Hapgood was correct, the implications were staggering. Someone, at some point in the deep past, had mapped the coastline of Antarctica before it was buried under ice. That someone had possessed the navigational skill to reach the continent, the cartographic skill to chart it with accuracy, and the means to transmit that knowledge forward through time until fragments of it eventually filtered into Piri Reis's sources. Who could have done that? Hapgood proposed an unknown ancient civilization, technologically capable enough to navigate the world's oceans and produce accurate maps existing thousands of years before the classical Greeks. He did not invoke aliens, he invoked lost human knowledge. A civilization that had been forgotten. His book received a favorable review from Albert Einstein, who wrote a foreword to an earlier edition of Hapgood's work on crustal displacement, though Einstein did not specifically endorse the ancient sea kings hypothesis. Hapgood's claims were picked up and amplified by a host of other writers, most famously Graham Hancock, who used the Piri Reis map as a key piece of evidence in his best-selling book, Fingerprints of the Gods. The map became a cornerstone of the lost civilization narrative, an artifact that seemed to prove that someone, long before recorded history, possessed knowledge we can barely replicate with modern technology. But the story is more complicated than most mystery enthusiasts like to admit. Critics of Hapgood's interpretation have raised serious objections. First, the identification of the southern landmass on the map as Antarctica is far from certain. Many cartographic historians argue that what Hapgood identified as the Antarctic coast is actually a distorted depiction of the southern coast of South America. In the early 16th century, the full extent of South America's southern coast was not yet known. Mapmakers routinely extended coastlines based on speculation, rumor, or the inherited assumption from classical Greek geography that a large southern landmass had to exist to balance the northern continents. This hypothetical terra australis appeared on many maps of the era, long before anyone had actually laid eyes on Antarctica. Piri Reis may simply have been following that convention. Second, Hapgood's claim that the map depicts Antarctica without its ice has been challenged on technical grounds. Detailed comparisons between the Piri Reis coastline and the actual subglacial topography of Antarctica do not match as cleanly as Hapgood suggested. The features he identified as specific Antarctic landmarks can be reinterpreted as artistic or speculative additions by Piri Reis or his sources. Third, the map's accuracy in other regions, while impressive, is not supernatural. Piri Reis had access to Portuguese charts derived from decades of aggressive exploration of the African and South American coasts, and he openly credits Columbus's own map as a key source. The accuracy falls within the range we would expect from a skilled cartographer compiling high-quality recent sources. So does the Piri Reis map prove the existence of a lost civilization with advanced cartographic knowledge? Almost certainly not. The scholarly consensus is that it is a remarkable but ultimately explicable product of early 16th century cartography, compiled from a mix of contemporary and older sources, and containing the typical errors, conventions, and speculations of its era. And yet, the Piri Reis map is not the only anomalous map from its period. The Orontius Phineas map of 1531 also depicts a southern landmass with features that some have compared to Antarctica. The Buache map of 1739 shows what appears to be a southern continent divided by waterways, which some have likened to the subglacial topography of Antarctica. Each of these has been explained by mainstream cartographers as variations on the Terra Australis tradition, speculative depictions based on theory rather than direct observation. But the recurring question lingers: why do so many early maps include a southern landmass? Why do some of them show features that, even by coincidence, resemble the actual geography of a continent that would not be seen for centuries? Is it all Greek philosophical speculation passed down through the ages? Or is there, buried somewhere in the long chain of source maps that Piri Reis and others drew upon, a fragment of knowledge that is older and stranger than anyone is quite comfortable admitting? The honest answer is that we do not know. The maps alone cannot prove the existence of a lost civilization. But they fit the pattern. They are another piece that does not quite slot into the conventional puzzle. Another anomaly. Another whisper. And the whispers are getting louder, because the maps are not the only evidence of ancient people doing things they should not have been able to do. In a region not far from where Piri Reis once sailed, in the volcanic heartland of modern Turkey, another impossible achievement waits. Not carved into a hilltop like Göbekli Tepe, carved downward into the earth, 18 stories deep. A city designed to shelter 20,000 people from something happening on the surface. Something so terrible that going underground was the only option. That city has a name: Derinkuyu, and it has been hiding for a very long time. Chapter 7: Cities Beneath the Earth. In 1963, a man in the Turkish town of Derinkuyu was renovating his house. He picked up a sledgehammer and swung it into a basement wall. The stone crumbled, and behind it he saw darkness. Not the darkness of a crawl space or a shallow cellar. A deeper darkness. A passageway. He pushed through the debris and found himself at the entrance of a tunnel. The tunnel led to a room. The room led to another tunnel. That tunnel led to another room. And another. And another. Descending. Always descending. What this unnamed homeowner had unknowingly broken into was one of the most extraordinary archaeological discoveries of the 20th century. An entire underground city carved from the soft volcanic rock of the Cappadocia region, extending approximately 85 meters or about 280 feet down into the earth. 18 levels deep, with ventilation shafts, water wells, storage rooms, stables, cellars, wine presses, oil presses, kitchens, meeting halls, schools, and chapels. Massive circular stone doors, each weighing several hundred pounds, could be rolled across corridor entrances from the inside, sealing the city shut against intruders. The doors could not be opened from the outside. The city was built for defense, for concealment, for survival. Derinkuyu could shelter up to 20,000 people, along with their livestock and food supplies for extended periods. The engineering is meticulous. The ventilation system, a network of shafts running from the lowest levels up to the surface, delivered fresh air throughout the complex. Some of those shafts doubled as wells, reaching down to the water table and supplying drinking water to the inhabitants. The air circulation was so well designed that even at the lowest levels, the atmosphere remained breathable. The city was organized with purpose. The upper levels served as living quarters and workspaces. The lower levels were used for storage and secure refuge. The narrow corridors, deliberately tight, ensured that invaders would have to move in single file, where defenders could pick them off one at a time. Every floor could be sealed off independently. If the upper levels were breached, the population could retreat deeper and close stone doors behind them. The design reflects military thinking, strategic thinking, the thinking of people who had survived attacks before and fully intended to survive them again. Derinkuyu is not alone. Cappadocia contains more than 200 known underground settlements. Some are small, only 2 or 3 levels. Others rival Derinkuyu in scale. Kaimakli, another vast underground city, sits just 5 miles away. Some researchers believe the two cities were once linked by a tunnel nearly 9 kilometers long, creating an underground network. In 2015, during the construction of a housing project near the town of Nevzahir, yet another underground city was discovered beneath a hilltop castle. Initial surveys suggested it might be even larger than Derinkuyu, extending over 100 meters deep and covering nearly 5 million square feet. Less than half of Derinkuyu itself has been excavated. Entire sections remain sealed off, either due to structural concerns or because no one has yet ventured into them. The conventional archaeological explanation for these underground cities is straightforward. Cappadocia lies at a crossroads of ancient empires. Hittites, Persians, Greeks, Romans, Byzantines, Arabs, Mongols, and Ottomans all fought for control of the region over thousands of years. The underground cities served as refuges during invasions. When armies appeared on the horizon, the local population descended into the rock, sealed the doors, and waited the threat out. Historical records confirm this use during the Byzantine-Arab Wars from the 8th through 12th centuries, during the Mongol raids of the 14th century, and even into the 20th century, when Cappadocian Greeks and Armenians used the tunnels to escape persecution. The earliest construction is generally attributed to the Phrygians, who inhabited the region in the 8th and 7th centuries BCE. The soft volcanic tuff was easy to carve with simple tools, and the Phrygians likely began excavating the upper levels. Later cultures, particularly Byzantine Christians, expanded the complexes dramatically, adding the chapels, the deeper levels, and the more sophisticated defensive features. This explanation is rational. It is well supported by the archaeological evidence. It answers the questions of who and why with reasonable confidence. But it does not answer all of the questions. The first unanswered question is one of scale. Carving a city capable of sheltering 20,000 people 18 stories deep into solid rock, even soft rock, is an extraordinary engineering achievement. It requires not just labor, but planning. Someone had to design the ventilation system before the first shaft was sunk. Someone had to calculate the structural loads to prevent collapse. Someone had to map the water table in order to know where to place the wells. Someone had to coordinate the labor of hundreds or thousands of people over what must have been decades, if not centuries, of continuous excavation. This is not the work of frightened villagers digging a hole to hide in. This is the work of engineers. The second question concerns origin. While the conventional dating places the earliest excavation in the Phrygian era, roughly 2,800 years ago, some researchers have questioned whether the deepest and most ancient portions of the complex may be significantly older. The lower levels of Derinkuyu show no Phrygian artifacts. The stonework is different. The design philosophy is different. Some alternative researchers have proposed that the lowest levels could date back to the Neolithic period or even earlier, with later cultures simply expanding a complex that was already there when they arrived. The third question is the most provocative of all. What were they hiding from? Invading armies is the standard answer, and for the historical periods we can document, that answer is sufficient. But the sheer depth of Derinkuyu raises eyebrows. You do not need to go 18 stories underground to hide from a cavalry raid. A few levels would be more than enough. The extreme depth suggests that whoever designed the deepest portions was preparing for something more than a passing army. They were preparing for a situation in which the surface itself was uninhabitable for an extended period of time. Some alternative researchers have drawn a connection between the underground cities of Cappadocia and the Younger Dryas event. Göbekli Tepe sits roughly 600 kilometers east. Both regions were inhabited during the same period. If a cosmic catastrophe struck the northern hemisphere 12,800 years ago, filling the sky with dust and debris, triggering wildfires and extreme cold, then going underground would have been a rational survival strategy. Not from human enemies, from the sky itself. This theory is speculative. There is no direct archaeological evidence linking Derinkuyi's deepest levels to the Younger Dryas or to any cosmic event. The conventional dating is far more recent, but the theory persists because it addresses the question of scale. Why dig so deep, unless you had a reason to fear the surface itself? There is another possibility that deserves consideration. Cappadocia is a volcanically active region. The soft tuff that made the underground cities possible was itself produced by ancient volcanic eruptions. The people of the region would have been intimately familiar with the dangers of volcanism, ash falls, pyroclastic flows, toxic gases. Going underground during a volcanic event is a rational response. And digging deep enough to ride out a sustained eruption that could blanket the surface in ash for months or years might explain the extreme depth of the complex. Whatever the original motivation, the underground cities of Cappadocia represent something remarkable. They represent a civilizational response to existential threat. Not just individual survival, not just a family hiding in a cave. An entire community, organized, provisioned, and engineered to survive beneath the surface for extended periods. They represent the understanding that sometimes the surface is not safe, that sometimes you have to go down. And that understanding echoes through one of the most persistent and widespread stories in all of human culture. A story told on every inhabited continent. A story told by peoples who supposedly had no contact with one another. A story about a time when the surface was not just dangerous but destroyed. A time when the water came and covered everything. The story of the flood. Not one flood story. Hundreds of them. Thousands of them. Told by the Sumerians and the Hebrews, by the Greeks and the Hindus, by the Chinese and the Norse, by the Aboriginal Australians and the Hopi, by the Aztecs and the Inca, by peoples on islands in the Pacific who had been isolated for thousands of years, all of them telling essentially the same story. The gods were angry, or the sky fell, or the waters rose, the world was destroyed, a few survived, civilization began again. If these stories are just myths, why are they everywhere? Why do they all say the same thing? And why do the geological details, when you strip away the mythological dressing, line up with what we actually know happened at the end of the Ice Age? That is the question we turn to now, the oldest stories ever told, and the unsettling possibility that they are not stories at all. That they are memories. Chapter 8. When the World Drowned. Nearly every culture on Earth tells a story about the end of the world, not a future apocalypse, a past one, a time when the water came and swallowed everything, a time when the gods decided to start over, a time when, out of the wreckage, a handful of survivors rebuilt and began again. The most famous version in the Western world is the story of Noah. God saw that humanity had become wicked. He decided to destroy the world with a flood. He warned Noah, a righteous man, and told him to build an ark. Noah built the ark, loaded it with his family and pairs of every animal, and survived the deluge. The waters receded. The ark came to rest on a mountain. Noah sent out birds to find dry land. A dove returned with an olive branch. The world began again. This story is preserved in the book of Genesis. It has been told for roughly 3,000 years. But it is not the oldest version. The oldest written flood story comes from ancient Sumer, the civilization that arose in southern Mesopotamia, modern-day Iraq, roughly 5,000 years ago. In the Sumerian king list, one of the earliest historical records ever compiled, the kings of the antediluvian world are listed with impossibly long reigns. Then comes a single line: the flood swept over. Kingship descended again from heaven. A new line of kings begins. In the Epic of Gilgamesh, the greatest surviving work of literature from the ancient world, the hero Gilgamesh travels to the end of the world to find Utnapishtim, the only man ever granted immortality by the gods. Utnapishtim tells Gilgamesh how he survived the Great Flood. The gods of Sumer decided to destroy humanity. But one god, Ea, warned Utnapishtim in secret, speaking through the wall of his reed house. "Tear down your house," Ea told him. "Build a boat. Load it with the seed of all living things. Utnapishtim built the boat. The storm came. It raged for 6 days and 7 nights. The waters rose until even the gods were terrified. When the storm passed, the boat came to rest on a mountain. Utnapishtim sent out a dove. It returned. He sent out a swallow. It returned. He sent out a raven. It did not return. The waters were receding. The world was beginning again. The parallels to Noah are unmistakable. A divine warning. A great boat. A catastrophic flood. Animals preserved. A mountain landing. Birds sent to find dry land. Scholars have long acknowledged that the Genesis account was influenced by the older Mesopotamian tradition. The earlier epic of Atrahasis, dating to roughly the 18th century BCE, tells a similar story with additional details about the gods, motivations, and the aftermath. The Sumerian Eridu Genesis offers yet another version. The flood story was central to Mesopotamian culture long before it ever entered the Hebrew Bible. But here is what matters for our investigation. The Mesopotamian flood stories are not unique. They are not even unusual. They are one expression of a narrative that appears in virtually every culture, on every inhabited continent. In Hindu tradition, the god Vishnu warns the sage Manu of an approaching flood. Manu builds a boat, loads it with seeds and animals, and survives. The boat is towed through the rising waters by a giant fish. After the flood, Manu performs a sacrifice, and from the offering, a woman emerges. Together, they repopulate the world. In Greek mythology, Zeus decides to destroy humanity with a flood. Deucalion and Pyrrha, the only righteous couple, survive inside a chest that floats on the rising waters. When the flood recedes, they land on a mountaintop and repopulate the earth by throwing stones over their shoulders, which become new people. In Chinese mythology, the sage Gun tries to stop a great flood by building dams and fails. His son Yu succeeds by dredging channels to divert the waters. The flood becomes a foundational event in Chinese civilizational memory, and Yu becomes the first ruler of the Xia dynasty. In Norse mythology, the world begins with the flood of Ymir's blood, and the gods create the earth from the remnants. Among the Aboriginal Australians, flood stories rank among the oldest continuously maintained oral traditions on the planet. These stories describe a great water that covered the land, reshaping coastlines and drowning entire regions. Some of them correspond to geological evidence of post-glacial sea level rise along the Australian coast, and researchers have suggested that they may preserve memories of real events stretching back 10,000 years or more. In the Americas, flood myths are ubiquitous. The Hopi tell of a world destroyed by water because the people had become corrupt. The Aztecs describe a fourth sun, a fourth age of the world, that ended in catastrophic flooding. The Maya Popol Vuh describes the destruction of an earlier creation by a great flood sent by the gods. South American indigenous traditions, from the Andes to the Amazon, contain similar accounts. The numbers are staggering. Scholars have cataloged over 500 distinct flood myths from cultures around the world. Many of those cultures had no known contact with Mesopotamia or with each other. They spoke different languages. They lived in radically different environments. They practiced different religions, had different social structures, and used different technologies. And yet they all tell the same essential story. The world was destroyed by water. A few survived. Civilization began again. The conventional explanation is cultural convergence. Floods, the argument goes, are a universal human experience. Nearly every human settlement in history has been built near water, on rivers, on lakes, along coasts, because water is essential for survival. And water inevitably floods. Every culture that lives near water has experienced catastrophic flooding at some point. Those local disasters become mythologized over generations, growing in scale and significance until they become creation narratives, stories about the end and beginning of the world. The flood myth in this reading is a natural product of the human condition, not evidence of a single historical event. This explanation has considerable merit, but it does not fully account for the specificity of the parallels. Many flood myths share structural details that go well beyond a generic flood happened and here is the story narrative. A divine warning. a chosen survivor, a vessel for preservation, animals saved. A mountain landing, birds sent to scout, a sacrifice of gratitude, a new beginning. Those details recur across cultures that had no apparent means of sharing stories. Is it possible that all of these cultures independently invented the same narrative structure? Yes, it is possible. Humans are pattern makers. We tell stories with heroes, crises, and resolutions because that is how our minds organize experience. But the degree of convergence is striking, and it invites an alternative explanation. What if the flood myths are not independent inventions? What if they are memories, not memories of a single simultaneous global flood? The physics does not support that. There has never been enough water on Earth to cover all land at once. But memories of a process, a prolonged, devastating process that affected coastlines and river valleys all around the world over thousands of years. At the end of the last ice age, beginning roughly 15,000 years ago and continuing until approximately 7,000 years ago, global sea levels rose by over 120 meters. That is nearly 400 feet. Coastlines that had been stable for tens of thousands of years were drowned. Entire land masses vanished underwater. The Bering Land Bridge between Asia and North America, the land connection between Britain and Europe, the vast Sundaland Shelf between Southeast Asia and Indonesia, the continental shelves of India, Australia, and the Americas, all submerged. The geographic transformation was immense. And it did not always happen gradually. While the overall trend was slow by human standards, it was punctuated by episodes of rapid flooding. Meltwater pulses, sudden releases of enormous volumes of water from collapsing ice sheets or bursting glacial lakes, could raise sea levels by several meters within decades. For coastal populations, this would have been catastrophic. Settlements drowned, fishing grounds destroyed, entire communities displaced. And if a particularly violent meltwater pulse coincided with a storm surge or a tsunami, the destruction would have been apocalyptic in local terms. Imagine a community living on a coastal plain 12,000 years ago. They have lived there for generations. The sea is their provider. Their culture is built around it. Then the water begins to rise. Slowly at first, the beach creeps closer. Camps have to be moved. Then faster. A storm rolls in, and the sea does not retreat afterward. Fields flood. Wells turn brackish. Within a single lifetime, the land their grandparents walked is underwater. And within a few more generations, there is no memory of it left except a story. A story about a time when the water came and took everything. A story about a world that drowned. Now multiply that experience across every coast of every continent. Repeat it for 8,000 years. Layer upon layer of loss. Generation after generation watching the sea swallow their world. Is it any wonder that every culture remembers a flood? And here's the final twist. If there was a civilization before our own, a civilization that existed during the Ice Age, when sea levels were 120 meters lower than they are today, where would it have been? Not in the highlands, not in the mountains. Civilizations cluster along coasts, along rivers, along the paths of trade and travel. They would have been on the continental shelves, the very lands that are now underwater. We have not looked there. We have barely begun. Marine archaeology is expensive, difficult, and narrow in scope. The submerged landscapes of the last ice age remain almost entirely unexplored. A few sites have been investigated. Doggerland, the former land bridge between Britain and Europe, has yielded tantalizing finds. Submerged structures off the coasts of India, Japan, and the Mediterranean have been reported, though their origins and significance remain debated. But the vast majority of the world's submerged continental shelves remain unexplored. We are, in effect, trying to read a book from which 99% of the pages have been torn out, and the remaining 1% has been damaged by water, fire, and time. And then we are declaring with confidence that we know the whole story. The flood myths may not be about divine punishment. They may be about real water, real loss, real memory, passed down across millennia in the only format that pre-literate peoples had available. Story, myth, legend, and perhaps, just perhaps, those stories are trying to tell us something we have not yet been willing to hear. Chapter 9. The Eraser. Let us pause here and talk about why this question is so difficult to answer. Not the question of whether a previous civilization existed. The question of whether we could even find it if one had. Because the Earth is not a museum, it is a machine. A machine that grinds, dissolves, subducts, melts, compresses, and erases. And it has been running for 4.5 billion years. Consider what would happen if our civilization ended tomorrow. Not in a nuclear war. Not in a bang. Just a quiet exit. Humanity vanishes. The machines stop. The lights go out. What happens next? Within weeks, most power grids fail. Within months, vegetation begins reclaiming the cities. Roots crack through pavement. Vines climb walls. Within a few decades, wooden structures collapse. Steel rusts. Glass shatters under thermal stress. The buildings we once thought permanent begin to crumble. Within a few centuries, most above-ground structures are gone, reduced to rubble. Within a few thousand years, the rubble is buried under soil and sediment. Within 100,000 years, the last traces of our cities are geological layers. Thin bands of unusual chemistry in the rock, concrete fragments, microplastics, elevated levels of heavy metals, a spike of radioactive isotopes from our nuclear testing. Within 1 million years, tectonic processes have resurfaced entire regions. Rivers have changed course. Coastlines have shifted. Mountains have risen and eroded. The specific locations of our cities can no longer be identified from the surface. The only way to find them would be to drill or to stumble upon an exposed cross-section, a cliff face, or a road cut that happens to intersect the thin layer where our civilization once sat. Within 10 million years, most of that layer has been subducted, eroded, or metamorphosed beyond recognition. Plate tectonics have pulled portions of our continental shelves into subduction zones, dragging them down into the mantle, where temperatures and pressures melt everything into magma. The chemical signatures persist in a few places, anomalous layers of carbon, nitrogen, and trace metals in sedimentary sequences. But they are subtle, ambiguous, indistinguishable in many cases from natural volcanic or hydrothermal events. Within 50 million years, virtually nothing physical remains. No structure, no artifact, not even a fossil of a human being. Because the conditions required for fossilization are rare, and the fraction of any species that becomes fossilized is vanishingly small. The dinosaurs dominated the Earth for more than 165 million years, and the total number of individual dinosaur fossils ever found could fit inside a single museum. An entire civilization lasting a few thousand years would be lucky to leave behind a single fossilized individual. What remains are chemical whispers, isotopic ratios, thin layers of unusual concentration in deep-sea sediment cores, the kinds of signals that geologists find all the time and reflexively attribute to volcanism, methane releases, orbital shifts, or other natural processes. Because until Frank and Schmidt asked the question in 2018, nobody was looking for anything else. This is the fundamental problem with the Silurian hypothesis. The Earth is not just vast in space. It is vast in time. And time is the great eraser. Given enough of it, the planet will destroy the evidence of almost anything that ever happened on its surface. Less than 1% of Earth's land surface is urbanized today. If you were searching for evidence of our cities 50 million years from now, you would be sifting through core samples representing less than 1% of the original surface area, of which most would have been recycled by tectonic processes. The odds of finding a direct artifact, a piece of concrete, a fragment of steel, a shard of glass, are essentially zero. You would have to rely entirely on indirect evidence, on chemical anomalies in the rock. And those anomalies, as we have already seen, can look exactly like natural events. Now consider the oceans. 71% of the Earth's surface is water. The ocean floor is not permanent. It is created at mid-ocean ridges, where magma rises and solidifies into new crust, and destroyed at subduction zones, where old crust dives back into the mantle. The oldest ocean floor on the planet is about 200 million years old. everything older has been recycled. Any evidence of anything that happened on the ocean floor more than 200 million years ago has been melted back into the interior of the Earth. Continental crust is older. Some rocks on the continents are nearly 4 billion years old. But exposed continental surface material from before the Quaternary period, the last 2.5 million years, is rare. Most of the Earth's continental surface has been resurfaced by erosion, sedimentation, glaciation, volcanism, or tectonic deformation. Finding undisturbed surface material from even 10 million years ago is difficult. Finding it from 50 million years ago is a needle in a continental haystack. And then there is sea level. This is perhaps the most underappreciated factor of all. During ice ages, when enormous volumes of water are locked into continental glaciers, sea levels drop dramatically. During the last glacial maximum, roughly 20,000 years ago, sea levels were approximately 120 meters lower than they are today. The coastlines of every continent extended far beyond their current positions. Vast areas of what is now continental shelf were dry land. If a coastal civilization existed during the Ice Age, and coastal is where civilizations overwhelmingly tend to develop, its remains are now submerged, covered by 120 meters of ocean water and 12,000 years of marine sediment. We have not looked there. Marine archaeology, the systematic exploration of submerged landscapes, is in its infancy. A handful of sites have been investigated. Doggerland, the land bridge between Britain and Europe, has produced intriguing finds. Submerged structures off the coasts of India, Japan, and the Mediterranean have been reported, though their origins and significance remain contested. But the vast majority of the world's submerged continental shelves remain unexplored. We are, in effect, trying to read a book from which 99% of the pages have been ripped out, and the remaining 1% has been singed, soaked, and gnawed by 12,000 years of environmental attack. And then we are loudly declaring with confidence that we know the whole story. The Silurian hypothesis does not claim that a previous civilization existed. What it claims is that our ability to rule one out is far weaker than we assume. The geological record is incomplete. The evidence, if it ever existed, has been subjected to millions of years of the most thorough destruction imaginable. And the specific signatures we would be looking for are exactly the kinds of signatures that natural processes also produce. This is humbling. It should be, because it means that our confidence in our own uniqueness, our certainty that we are the first and only technological civilization to emerge on this planet, rests not on proof, but on the absence of disproof. And in a system where evidence is systematically destroyed over time, the absence of evidence is a very shaky foundation indeed. Does this mean a previous civilization existed? No. The most parsimonious explanation for the evidence we have is that we are, in fact, the first. The simplest interpretation of the geological record is that the anomalies we find are natural in origin, products of volcanism, orbital forcing, and the complex interplay of carbon and climate across deep time. But the most parsimonious explanation is not always the correct one. For centuries, the most parsimonious explanation for the diversity of life was special creation. For decades, the most parsimonious explanation for continental shapes was coincidence. For years, the most parsimonious explanation for mass extinctions was gradual climate change, until the Chicxulub impact crater proved that sometimes the universe throws rocks at us. Science advances by questioning assumptions, by looking at the evidence with fresh eyes, by asking whether the story we tell ourselves is the only story the evidence actually supports. And the evidence, when you lay it all out side by side, supports more than one story. The PETM, with its carbon isotope signature that mirrors industrial activity. The Younger Dryas, with its sudden onset, its megafauna extinctions, its cosmic impact markers. Göbekli Tepe, with its impossible sophistication at the impossible date. The Sphinx, with its water erosion in a desert. The maps that show things no one should have known. The underground cities built to survive something on the surface. The flood myths, told by every culture, describing the same catastrophe. Each of these, taken individually, has a conventional explanation. And each conventional explanation is reasonable, probably correct. But taken together, they form a pattern of anomalies, a pattern of things that do not quite fit, a pattern that, if you squint, if you tilt your head, if you are willing to entertain the possibility, looks like the shadow of something we have lost, something that was here before us, something that rose and fell and left only the faintest of traces. Traces that we are just now, in the first decades of the 21st century, beginning to learn how to look for. That is not proof. It is not even evidence in the strict scientific sense. It is a question, a haunting, beautiful, terrifying question. And it is the question we will try to answer as best we can in our final chapter. Chapter 10. What if we are the second try? So here we are at the end of the journey, or perhaps at the beginning of one. We have traveled from the laboratories of NASA scientists to the geological record of 56 million years ago. We have followed the trail of a comet through the skies of 12,800 years past. We have stood inside a temple that predates agriculture by thousands of years. We have run our fingers along the rain-carved grooves on a monument in the desert. We have unfolded a map that shows a continent 3 centuries before its discovery. We have descended 18 stories beneath the surface of the Earth. And we have listened to the oldest stories our species has ever told. Now we have to ask the question we have been building toward all night. What if we are not the first civilization on this planet? What does that mean? And does it even matter? Let us begin with what we know for certain. We know that the Earth is 4.5 billion years old. We know that complex life has existed for over 500 million years. We know that intelligent, social, tool-using animals have existed for tens of millions of years. We know that our species, Homo sapiens, has been around for roughly 300,000 years. We know that our industrial civilization, the one that builds skyscrapers and splits atoms and sends robots to Mars, has existed for about 300 years. 300 years out of 4.5 billion. We know that the geological record is incomplete, that tectonic processes recycle the ocean floor every 200 million years, that erosion, subduction, and metamorphism systematically destroy surface evidence over millions of years, that less than 1% of Earth's surface is urbanized, that the chance of finding artifacts from a civilization that occupied a similar fraction millions of years ago is vanishingly small. We know that the chemical signatures an industrial civilization would leave behind, carbon isotope excursions, trace metal anomalies, synthetic molecule traces, are similar to, and potentially indistinguishable from, the signatures of natural events like volcanism and methane hydrate releases. We know that the PETM, 56 million years ago, produced a chemical signature in the geological record that is the closest known ancient analog to what modern industrial civilization is doing to the planet. We know that its exact trigger remains debated despite decades of research. We know that roughly 12,800 years ago, something catastrophic happened. The Younger Dryas cold period began abruptly. Megafauna went extinct across multiple continents. The Clovis culture vanished. A growing body of evidence suggests a cosmic impact may have played a role. Though this remains controversial, we know that Göbekli Tepe exists. That it was built by people who, according to every other line of evidence, were hunter-gatherers without the organizational or technological capacity to create it. That it was built immediately after the Younger Dryas ended. That its sophistication implies knowledge and skills that did not appear from nowhere. We know that the Great Sphinx shows erosion patterns that at least some qualified geologists attribute to prolonged rainfall. Rainfall that has not occurred in the region for thousands of years before the conventional date of the Sphinx's construction. We know that ancient maps contain features that are difficult to explain with the cartographic knowledge available at the time of their creation. We know that underground cities of extraordinary depth and sophistication exist in Cappadocia, with origins that are not fully understood. And we know that virtually every culture on Earth tells a story about a great flood that destroyed the world and forced humanity to begin again. Stories with structural parallels that are difficult to explain through independent invention alone. None of this is proof. Let us be absolutely clear about that. None of this proves that a previous civilization existed on Earth before our own. The conventional explanations for each of these phenomena are reasonable and, in most cases, probably correct. The PETM was caused by volcanism and methane releases. The Younger Dryas was triggered by freshwater discharge into the North Atlantic. Göbekli Tepe was built by exceptionally capable hunter-gatherers. The Sphinx was carved by Khafre. The Piri race map is a product of 16th century cartographic convention. The underground cities were refuges from historical invasions. And the flood myths reflect the universal human experience of living near water that occasionally rises. These explanations work. They are supported by evidence. They do not require us to invoke lost civilizations or ancient catastrophes that erased all trace of a previous world. But there is always a but. But taken together, these anomalies form a pattern of things that are slightly off, slightly harder to explain than they should be, slightly more connected than they should be. A pattern that invites, though it does not demand, a different kind of explanation. And here is what that explanation might look like. Not as proven fact, but as a possibility, a thought experiment, like the Silurian hypothesis itself. Imagine a civilization that arose during the Ice Age. Not our kind of civilization. Not one that burned fossil fuels and built nuclear reactors. A different kind, one that developed along different technological lines. Perhaps one that was more maritime than terrestrial. Built along the coastlines of Ice Age continents, where the climate was mild and the seas were rich. A civilization that developed astronomy, navigation, agriculture, architecture, and social organization, but that left a lighter footprint than we do. A civilization that understood the earth and the sky in ways we are only now beginning to rediscover. Imagine that this civilization was struck by a catastrophe. A comet impact, a sudden climate shift. Rising seas that drowned their coastal cities. Fire and ice and flood, all within the span of a few generations. Not everyone died, some survived. Some carried knowledge with them. Fragments of astronomy, agriculture, navigation, engineering. And they spread across the world, teaching what they knew to the hunter-gatherer populations they encountered. Imagine that these survivors built Göbekli Tepe as a memorial and a repository of knowledge. That they carved the Sphinx as a marker oriented to the stars at a specific moment in time. That they passed down stories of the catastrophe. Stories that became the flood myths of Sumer and India and Greece and the Americas. That their maps, their charts, their understanding of the world's geography filtered down through millennia of copying and recopying until fragments of impossibly accurate information appeared on a gazelle skin map in 1513. Imagine that the evidence of their coastal civilization lies exactly where you would expect it. Under 120 meters of ocean. On continental shelves we have not explored. In sediment layers we have not examined. In the gaps of a geological record that we have only just begun to read. This is the story Graham Hancock tells. It is the story that alternative researchers have been trying to tell for decades. And it is a story that mainstream science overwhelmingly rejects. The rejection is not unreasonable. Extraordinary claims require extraordinary evidence. And the evidence, while suggestive, is not extraordinary. It is circumstantial. It is interpretive. It depends on choosing specific readings of ambiguous data and weaving them into a coherent narrative, while ignoring or downplaying the conventional explanations. But the rejection is also not the final word, because science is not static, it is a process. And the process involves testing hypotheses, gathering new evidence, and revising our understanding when the evidence demands it. The Silurian hypothesis was published in a peer-reviewed journal. It was not a conspiracy theory, it was a formal scientific inquiry into the limits of our knowledge. And its conclusion was not that a previous civilization existed, its conclusion was that we cannot rule one out, and that admitting what we do not know is the first step toward finding out. So what do we do with all of this? First, we keep looking. The submerged continental shelves of the Ice Age world represent one of the largest unexplored archaeological frontiers on the planet. As marine archaeology technology improves, as sonar and remote sensing and underwater robotics become cheaper and more capable, we will begin to map those landscapes. And what we find there may change everything. Or it may confirm what we already believe. Either way, we need to look. Second, we keep questioning. The narrative of human progress, from primitive hunter-gatherers to sophisticated civilizations in a neat upward line, is a story we tell ourselves. It is not the only story the evidence supports. Göbekli Tepe alone should make us humble about what we think we know about our ancestors. If they could build that, what else could they do that we have not yet discovered? Third, we take the warning seriously. Whether or not a previous civilization existed, the Silurian hypothesis carries a message that is absolutely relevant to us right now. We are leaving a mark on this planet, a deep, indelible chemical mark. We are changing the atmosphere. We are changing the oceans. We are driving species to extinction at a rate that matches the great mass extinctions of the deep past. We are, in geological terms, creating our own PETM. And if we do not change course, the question future geologists will ask is not whether our civilization existed, it will be what happened to it. The Earth does not care about us. It does not care about our cities or our art or our arguments about lost civilizations. It will spin and shift and erode and subduct and recycle, regardless of what we do. It has done so for 4.5 billion years. It will do so for billions more. The question is not whether the Earth will survive. It will. The question is whether we will leave anything behind that matters. Or whether, like the hypothetical civilization of the Silurian hypothesis, we will be reduced to a thin, ambiguous line in the rock, a chemical whisper that a future species might find and wonder about, if they are smart enough to look. We might not be Earth's first civilization, but even if we are, we share something with every form of life that has ever existed on this planet. We are temporary. The rock is patient, and the only things that survive are the things we care enough to preserve. The Egyptian pharaohs carved their names into stone because they wanted to be remembered. The builders of Göbekli Tepe created something so remarkable that it survived 12,000 years of burial. The people who told the flood myths passed their stories down through generations so long that the stories outlasted the civilizations that first told them. We remember what we choose to remember, and we forget what we fail to protect. So the next time you look up at the night sky, or stand on a beach where the waves erase your footprints, or hold a handful of soil and think about all the life that has passed through it, ask yourself this question: if someone came before us, what did they want us to know? And if no one did, what do we want to leave for whoever comes next? The house survived because it learned to serve. The story survived because someone thought it mattered enough to tell. If you enjoyed this deep investigation into science, history, and the mysteries of our past, please like this video and subscribe to the channel. Your support is what makes these detailed stories possible. Tell me in the comments, do you think we are Earth's first civilization? Or is there something buried in the deep past that we have not yet found? And what should we investigate next? These are not just questions for scientists. They are questions for all of us. Because the past is not a closed book. It is an open dig. And every new discovery changes the story. Thank you for watching. I will see you in the next investigation.